For example, you know about this continuous modes, right? We started with continuous build, then started with continuous integration, right, in the past. Right? Then it's about continuous delivery, and then it's about continuous deployment. You can't get to the last one unless you have all these in place. Right? And it doesn't matter whether even if you have continuous delivery, it doesn't matter all of them are deployed. Right? Not many of them may be deployed, but it's your choice.
So one maybe last one.
Let's keep
from
other
cultural
questions
change
for the
perspective.
panel.
I know the cultural change is a very big one because everything else is technology can be easily manageable. So I think, and this is a big question, I think possibly cannot be answered in a few minutes, but the question is, what is the impact on roles? So the roles are not going away, right? You will still have project managers, you will still have engineers, you will still have build and release engineers, you will still have people who manage infrastructure, you will still have people who manage databases and stuff like that. But what is the impact on different roles? And how does it all come together collaboratively to make all these things happen in a continuous way?
Great question. I typically include my talk, right, because I want to keep it at a high level initially. So it's all about it's not about people collaborating with each other. It's not about teams collaborating, right? It's about the tools collaborating with each other. When I say tools, it's about the processes, it's about the roles, right? You want the roles to collaborate with each other, right? So what we have done is, we have, the toolset what we have is in a way that you can easily collaborate with each other without stepping on each other's toes. Everybody is aware of what is happening on the other side. Nobody has to go and ask anybody where you are. It's totally in the open. Right? And how we achieved it, right? That is what the collaborative lifecycle management is all about. Right? So I encourage you to take a look at the DevOps, right, on jazz.net, which is, and also there is a learning circle on DeveloperWorks. I give DeveloperWorks about DevOps. So if you are going to get these slides, then these images are essentially hyperlinks. You can click on them and it will take you to the respective.
Pradeep is here whole day, and we have a panel discussion at the end of the day, and you can shoot those questions then. I would like to have a warm round of applause for Pradeep for sharing this. We have a thought leadership certificate. We'd like to have Professor Gautam Mitra, Managing Director of UNICOM. Please come and hand over the certificate to Pradeep for this session.
That was a great talk and great introduction. And I'm really impressed with all of you here and for you taking forward the class. So see you after tea.
Yes. So we'll break for half an hour. The tea and coffee is being served just outside the door as soon as you move. The restrooms are further towards the right, and there are more restrooms if you go straight. So feel comfortable. If you have any problem with the room temperature, with anything, we have many UNICOM representatives here. You can reach out to us. We'll meet in exactly half an hour from now. Thank you. All the DevOps professionals, they are on Twitter. So those who do not have, please reach out to us. How can you use your Twitter to reach out to the community? Thank you. Should be there. We are even happy to do that. So Matthew, over to you, and on your talk on software operator.
Thank you. Can you hear me at the back? Raise your hand at the back if you can hear me. Perfect. Thank you. So, I want to talk about four things actually, today. Software operability, runbook collaboration, and then how we can make operability itself work well. I'll also talk about DevOps, of course, it seems we're here at Devops Summit. So just a very, very quick background about me, just to set the scene. I've been building and operating commercial software systems since 1998. I have specialized recently in build and deployment, and I've increasingly, as Ritesh said, been involved in DevOps, and practicing and talking and speaking about it and helping people to get to grips with it. I started a meetup group in London, which is where I'm based, on continuous delivery, which, as we heard from very earlier, there's a relationship between DevOps and continuous delivery. They're not identical, but they are cousins, if you like. And along with two colleagues of mine, I run a workshop series called Experience DevOps. We had the first India date yesterday, 19 or 20 people close by to here, and we've got another workshop in Delhi tomorrow. I'll mention a little bit more about that later in case anyone's interested. So, I want to talk about software operability, and the reason why I want to talk about that in the context of DevOps will be hopefully clear a little bit later on. And I will link software operability to DevOps in a few slides. So we'll define software operability, look at some examples, and then answer a question, well, why focus on operability? Why is that interesting? And see how DevOps can help us make our software systems more operable. First of all, though, what does the word operability mean? It looks like it could mean something to do with this. High Italian opera, people, generally large people singing very loudly. So I can assure you it's not about that. Although if anyone wants to make an opera about DevOps, then contact me and we'll see what we can do. I think that could be quite fun. So some words which might remind us of or relate to the word operability. We've seen opera. You could think of operate, operational, and a word that's perhaps more common than operability is interoperability. I think you can start to understand where the meaning lies for operability. And it turns out that operability relates to how well things work. The reason why, in case you're wondering why the word opera is related, it turns out the word opera simply means a work, as in a musical work. And that's the reason why this is relevant. So all of these are about working, or how things work. So if we wanted to have a definition of software operability, then we'd say something like this: it's the properties of a system which make it work well in production. I don't think anyone would disagree that that's a good goal to have. We definitely want stuff working well in production. However, that goal or that requirement is very often not high on the list of priorities for people who are building software systems with results that I think we're all familiar with, in that there are bugs in production and which have to be fixed, which is very costly. I wanted to, here's an example of a system which is, I would say, is highly operable. It's not a software system, but it demonstrates a high level of operability. This is an electric train which goes through the mountains in an island called Mallorca, which is in Spain. And it was built by German company Siemens in 1929, and it's still running today. I took this picture on holiday a couple of years ago, and those trains which were built, what's that, the best part of 100 years ago, are still running today. So the way in which they were built, the way in which they can be maintained, the way in which repairs can be made, it was clearly built in a way, it was built to last, it was built to work well in its production environment. There's a guy called David Copeland, you'll find him on Twitter, and he says that there's a reference, a URL to his blog where he says this. You'll be able to find it on the slides later. But he says this: how your software runs in production is all that matters. The most amazing abstractions, clean as code, or beautiful algorithms are meaningless if your code doesn't run well on production. So that's quite an extreme statement, certainly for some people. If you were to kind of pick some pieces out of that, you could argue, and by the way, I'm not saying that I believe what I'm about to say, but you could argue this: that forget about object orientation, forget about UML diagrams, forget about all this stuff. If it doesn't work well in production, what's the point? Now, I don't exactly believe that, but you can see the sorts of thinking that you would. It's about priorities. If your priority is on clean abstractions of business ideas and very well executed, very well implemented code with 100% unit test coverage and so on, but you've forgotten to make sure that it can scale horizontally, or you've forgotten that to make sure it can work behind a load balancer properly, or something else like this. What's the point? Because code running in production is serving our customers, serving our users, is the point of writing code in the first place. So a focus on how well. Let's go on.